Okay, good morning everyone. So at this time, we'll talk on about evaluating the limits of radical and rational functions. So actually, this topic is taken from the basic calculus subject in grade 11, STEM, particularly the STEM. So we will talk on now three examples. We have here number one, or we have evaluate the following limits. Now we have here number one, limit of the square root of x squared plus 1 over 3x minus 3 as x approaches to infinity. The second one, limit of 3x squared over x squared minus 9 as x approaches to negative infinity. So how do we evaluate these limits, particularly if a certain variable will approaches to infinity? So of course, to do that one or to answer that problem, or to evaluate the limit of this type of function, all we have to do is, we will have to divide each term by a variable containing the highest exponent. No? So as we observe in the first one, the variable that has highest exponent, we have x, to the power of 2. So therefore, this variable having x squared or having 2 as a power, that will be the variable that we're going to divide each term. Okay, so we will have to solve for number one. Okay, solution for number one. Okay, so we will have to divide each term from the numerator and denominator by the highest exponent. So this will become limit of, limit of square root of x squared over x squared plus 1 over x squared. Okay? Over, we have here 3x minus 3 or 3x over absolute value of square root of x squared, because we will have just only the positive values, minus 3 over absolute value of square root of x squared. Okay? As x approaches to infinity. Okay? So after that, we can now solve for this one. So, or we can now simplify, so that will become limit of, we have here square root of 1 plus 1 over x squared over, we have here 3x over absolute value of square root of x squared is x, minus 3 over x as x approaches to infinity. Then continue simplifying, that will become, that will become limit of square root of 1 plus 1 over x squared, over 3, because x divided x, the remaining one is 3, we have minus 3 over x as x approaches to infinity. At this time, we can now evaluate, we can now evaluate this one. So using the limit laws, we have here limit of, we have here, if we're going to evaluate, pwede na actually, wala ang limit, so we have here square root, of limit of 1 as x approaches to infinity. Plus limit of 1 over x squared as x approaches to infinity. Over, we have here limit of 3 as x approaches to infinity minus limit of, we have here 3 over x as x approaches to infinity. So we also have here, in the previous topic, we have actually the limit for the constant. If you have here limit of c as x approaches to a, still the answer is c. Meaning that is the limit for the constant. So you can now use that property. So from this time, that will become, or that is equally equal, that is equivalently equal to 1. Plus 1 divided by x squared, or if you are going to replace that one by infinite number, meaning huge, no? Dako kay siya nga number. So if we're going to divide that one by the highest or kung sa pinakadako na number, this will become possibly 0. Yung gamay. Or the value of this function, 1 over x squared, approaches to 0. So that will become 0. Over, we have here, again, this is 3 minus 3 over x divided by the highest number. Still, this one is approaches to 0. So, it will become 0. Then, continue simplifying. We have here square root of 1 over 3, or that is equivalent to 1 over 3. So, the answer is 1/3. Okay? So, let us now proceed to the second one. No? Number 2. Limit of 3x squared over x squared minus 9 as x approaches to negative infinity. Again, the same pattern that we will be doing, we will divide each term by the highest exponent, which is x squared. So this is equivalent to limit of 3x squared over x squared over, we have here x squared over x squared minus 9 over x squared. As x approaches to negative infinity. Okay? Then, when we simplify, we get limit of this one, we have here 3. Then, in the denominator part, this will become 1 minus 9 over x squared. As x approaches to negative infinity. Okay? Then, simplifying again, we get, we have here, applying the limit laws. We can have limit of 3 as x approaches to negative infinity, okay, over limit of 1 as x approaches to negative infinity minus limit of 9 over x squared as x approaches to negative infinity. Then that is actually equivalent to 3 over we have here 1 minus 9 divided by x squared. If we replace this one, biggest or the highest number, because x approaches to negative infinity, this one is actually approaches to 0. So the answer is 3 over 1, or that is equivalent to 3. Okay? So this is how you solve or this is how we are going to solve or evaluate the limits, particularly radical and rational function that involves infinity. First thing to do is we will have to divide each term by the highest exponent. Then after that, by simplifying, then we can actually now apply the laws for the limits, no, or limit laws. So I hope you will understand this one, so that you could answer some of your assignment, which is similar to the given examples.